I, Dr. Samta Gajbiye, welcome you all on SWAM online course on rule-based systems. Inference rules provide the foundation for automatic logical reasoning and decision making in artificial intelligence. They enable computers to systematically deduce conclusions from the existing knowledge, thus contributing to the process of generating new insights and expanding the realm of intelligent computational capabilities. Creating new logic through inference. Think of artificial intelligence as teaching computers to think as we want computers to be smart enough to figure out new things based on what they already know or what they see. So, when a computer uses what it knows to come up with new ideas or conclusion, we call this as a inference. It is like you are using your knowledge to solve a puzzle you have never seen before. What is inference rule? Inference rules are like magic patterns that help computers think logically. They are like recipes that computers follows to make smart guesses. These rules are used to create valid arguments which are like convincing explanations. When the computer follows these rules step by step, it is like a detective putting together clues to solve a mystery. Imagine you are building a case to prove something like in a detective story. In AI, we do something similar. We use inference rules to create a sequence of steps like putting puzzle pieces together to show that our idea or conclusion is correct. This sequence of steps is called a proof, and it is like a road map that leads us to our goal of being sure about something. We also use in the inference rules various connectives and the implications. So, connectives are like the building blocks of logic. They help us put ideas together in meaningful ways. One important connective is implication, that is a forward arrow, which is like saying if this happens then that happens. It is like when you tell your friend if you finish your homework then you can play later. In AI, understanding how the things are connected is crucial and for making smart decisions. By using these tools, we are teaching computers to think, reason and solve problems just like detective putting together clues to crack a case. Continuing with the rules of inference, we will see the various terminologies that are used in the inference rules. Implication is like making a deal in logic. So, if I finish my work P, then I can watch TV, that is Q. So, implication is a fundamental logical connective denoted by the symbol forward arrow. In the expression P implies Q, P is the antecedent or premise and Q is the consequent or conclusion. It asserts that if P is true, then Q is also true. Inverse, the another terminology used in inference rule is inverse. The inverse is like changing your mind about the deal. If you negate or say the opposite of both sides of the promise, it becomes the inverse. For example, if I do not finish my homework, that is negation of P, then I will not watch TV, that is negation of Q. It is like saying if I do not do my homework, I will not get TV time. The inverse of implication, that is P implies Q, is formed by negating both the antecedent and the consequent, that is not P implies not Q. It states that if P is false, then Q must also be false. However, the inverse does not necessarily have the same truth values as the original implication. The another term that we use is converse. Converse flips the promise around. Instead of saying if homework then TV, you say if TV then homework. It is like saying if I get to watch TV, that is Q, then I must have finished my homework, that is P. So, converse is like seeing if the deal can work both the ways. The converse of implication P implies Q is obtained by switching the positions of antecedent and consequent, that is Q implies P. It expresses that if Q is true, then P must also be true, Unlike the original implication, the truth of the converse does not guarantee the truth of original implication. Next term that we use in inference rule is contrapositive. The contrapositive is like turning the tables on both the sides of promise and flipping them. Instead of saying if no homework then no TV, that is not P implies not Q, you say if no TV then no homework, that is not Q implies not P. It is like saying if I did not get TV time then I must have finished my homework. The contrapositive of an implication P implies Q is formed by taking the inverse of the converse, not P implies not Q. It states that if Q is false then P must also be false. Interestingly, the contrapositive of an implication is logically equivalent to original implication itself. This terminology play a crucial role in logical reasoning and are essential in understanding the relationships and implications between propositions. Inference rules involving these concepts help guide the process of deriving valid conclusions and making logical deductions in various applications of artificial intelligence and logic. Equivalence can be proved using the truth table. So, what is a truth table? A truth table is like a special tool we use to check if different statements mean the same thing. It helps to see if two statements are like twins, they might look different, but they actually have the same logic. So, first we need to set up the truth table. First we list down all possible combinations of truth values for our statements. We will look at both the sides of equivalences, P implies Q and not Q implies not P. Filling in the second step is filling in the truth table values. We will fill the truth values based on the logic rules. For P implies Q, we check if Q follows from P. For example, if P is true and Q is false, then P implies Q is also false. We do the same for not Q implies not P. To make the truth table, we have to compare the columns. Now, we look at the columns for P implies Q and not Q implies not P. We compare them row by row. If both the columns have same truth values in all rows, it means the statements are equivalent. Then we can draw the conclusions. Looking at our truth table, if the columns for P implies Q and not Q implies not P match in every row, then we can confidently say that P implies Q is equivalent to not Q implies not P. Similarly, we can do the steps for Q implies P and not P implies not Q. If their truth value columns match in every row, we prove that Q implies P is equivalent to not P implies not Q. In simple words, a truth table helps us compare statements by checking if they behave the same way in all situations. If we see the two columns are the same for both the sides of an equivalence, we can say that those statements are like secret twins. They might look different, but they mean the same thing. So, by using the truth table, we have shown that P implies Q is like a mirror image of not Q implies not P, and Q implies P is like a secret twin of not P implies not Q. So, in rules of inferences, we will be discussing the different types of inference rules. One of the inference rule is modus ponens inference rule. Think of modus ponens like a detective's logical trick. It helps us figure out what's true based on what we already know. So, what is the modus ponens rule? It says that if we have two pieces of information, one piece, if something that is P happens, then something else that is Q will happen. P implies Q. The first thing P is true, then we can confidently say that the second thing Q is true. Example, let us see the example of real life to understand the situation. Suppose that if I am sleepy, then I go to bed. P is I am sleepy and Q is I go to bed. Using modus ponens, if we apply the modus ponens rule to this situation, then we say that if I am sleepy, then I will go to bed. That is P, if I am sleepy, then Q, I will go to bed. And we also know that I am indeed sleepy, that is P. So, based on modus ponens, we can confidently say that I go to bed, that is Q. In simple words, modus ponens is like a magic trick for logical reasoning. If we know two things, a promise that if one thing happens, another thing will happen, and the first thing is true, then we can be sure that the second thing will also happen. This can be demonstrated. The validity of modus ponens rule can be demonstrated using the truth table. Another type of rules of inference is modus tollens rule, and its example is, think of modus tollens like a cool detective trick in logic. It helps us figure out something by ruling out other possibilities. The rule is, if we have two things, if something, that is P, happens, then something else Q will happen. P implies Q, but the second thing, that is Q, didn't happen, that is not Q. Then we can smartly say that the first thing P didn't happen, that is not Q. So, let us see this through the example, real life example. If I am sleepy, then I go to bed, that is P implies Q. I did not go to bed, not Q. Using modus tollens now, let us apply the modus tollens rule to this situation. We know that if I am sleepy, P, then I will go to bed, Q, but we also know that I did not go to bed, that is not Q. So, using modus tollens, we can cleverly say I am not sleepy, that is not P. This modus tollens rule can be proved using the truth table, same as in the previous case for the modus ponens rule. The another rule of inference is hypothetical syllogism rule, and it can be explained through one of the example. The hypothetical syllogism rule is, if we have three things that connect like a chain. The first, if something P happens, then something else, that is Q, will happen, that is P implies Q. And if that second thing, that is Q, happens, then something else, that is R, will happen, that is Q implies R. Then we can cleverly say that if the first thing happens, then the last thing R will also happen, that is P implies Q. We can say that P implies Q, Q implies R, and from this we can draw the conclusion P implies R. So, let us see this with the real life example. If you have my home key, then you can unlock my home, P implies Q, where P is if you have home key, Q is you can unlock my home. Then the second is, if you can unlock my home, which is Q, then you can take my money, which is R. So, we can say that Q implies R. Using the rule of hypothetical syllogism, we found that if having my home key P means you can unlock my home, that is Q, and if unlocking my home Q means you can take my money, that is R. According to hypothetical syllogism, we can cleverly say, if you have my home key, which is P, then you can take my money, which is R. So, P implies R. So, same as the previous for modus ponens and modus tollens rule, this can also be proved using the truth table, which confirms that whenever both the premises P implies Q and Q implies R are true, then the conclusion P implies R is also true. This verifies the validity of the rule. So, let us explain the another rule, that is disjunctive syllogism. The rule is, if we have two things, either one thing happens, that is P, or another thing happens, that is Q, P or Q, but we know that the first thing, that is P, did not happen, that is not P, then we can confidently say that second thing must have happened, that is Q must have happened. Let us see this with the example, one of the situation. Today is either Sunday or Monday. So, P is Sunday and Q is Monday. The second is today is not Sunday, that is not P. Using disjunctive syllogism, now let us apply the rule to this situation. We know that today is either Sunday P or Monday, that is Q, but we also know that today is not Sunday, that is not P. So, based on disjunctive rule, we can confidently say that today is Monday, that is Q. Same as the previous, this can again be proved using the truth table for the premises, that is P or Q and not P, and then show the resulting truth table for the conclusion, that is Q. Another rule is the addition rule, and its example can be seen as, so first let us first see the rule. Think of the addition rule as a way to add things up in a logic. It helps us say that if we have one thing, then we can also have a bigger set that includes that thing. The rule is, if we know one thing is true, that is P, then we can confidently say that a bigger thing that includes the first is also true, P or Q. Let us see the simple example to understand this better situation. I have a vanilla ice cream which is P. Using the addition rule, now let us apply the addition rule to this situation. We know that I have vanilla ice cream which is P. The addition rule, let us say that I have a bigger set of ice cream which includes either vanilla or chocolate, that is P or Q. So, based on the addition rule, we can confidently say that I have vanilla or chocolate ice cream, that is P or Q. For the addition rule, the truth table will confirm that whenever the premise P is true, the conclusion P or Q is also true. This establishes the validity of the rule. The next rule is the simplification rule. Think of the simplification rule as a way to make things simpler or in logic. It helps us break down a bigger idea into its smaller parts. The rule is, if we know two things are true together, P and Q, then we can confidently say that each of these two things is true on its own, Q or P. Let us see the example to understand in a better way. I have banana which is P and an apple which is Q, that is P and Q. Using the simplification rule, now let us apply the simplification rule to this situation. We know that I have both a banana and an apple, that is P and Q. The simplification rule lets us say that I have a banana P and I have an apple Q. So, based on the simplification rule, we can confidently say I have an apple Q and I have a banana P. The simplification rule can be effectively proved through the truth table which has been shown here. The last rule of inference is resolution rule, and its example using simpler language for the students can be stated as, if we have two things, either one thing P happens or another thing Q happens, that is P or Q, and we also know that the first thing P is not true, but a different thing R is true, that is not P and R, then we can smartly say that the second thing, that is Q, or the different thing, that is R, must be true, that is Q or R. Let us see this with the example which can be better understood. Either I have a cat P which is P, or I have a dog which is Q. So, it can be written as P or Q. Then I do not have a cat, that is not P, but I have a fish, that is R, then it can be written as not P and R. Using the resolution rule, we know that either I have a cat P or I have a dog, that is Q, but we also know that I do not have a cat, that is not P, and instead I have a fish, that is R. So, based on the resolution rule, we can clearly say I have a dog or I have a fish, that is Q or R. So that was the last inference rule, that is the resolution rule. So this is the end of our discussion on based on the rule based system. Thank you. So we have already discussed the concepts of rule based systems. We will further look into the applications of rule based systems across different domains, and by illustrating their successful integration in industries such as healthcare, finance, manufacturing and logistics, readers gain a deeper understanding of how these systems revolutionize problem solving. So, first let us recap about the rule based systems and then we will switch to its application. Imagine you are teaching a super smart computer how to understand and make decisions, almost like teaching a robot how to think. That is what a rule based system does in computer science. It is used to store and manipulate knowledge. This means that this computer brain stores knowledge in the form of rules, kind of like instructions that help the computer make sense of things. It uses those rules we talked about to interpret data, messages and even questions. It is like giving the computer a set of tools to figure out what is happening or what to do next. Also, the rule based systems are used in artificial intelligence application, which means they help computers do tasks that usually need human like thinking. The rules in the rule based systems are created by humans. These rules are carefully crafted by people who understand the problem and know how to solve it. In a nutshell, we can say that a rule based system is like giving a computer a set of rules or instructions to help it think, understand and make decisions. It is a way to make computers smarter and more useful. It is used to in things like talking to virtual assistants, playing strategy games and so much more in the world of technology. In a rule based system, there are two important elements. One is a set of rules and a set of facts. Every rule specifies a relation, recommendation, directive, strategy or heuristic and has if then else structure. As soon as the condition part of the rule is satisfied, the rule gets triggered and the action parts get executed. For example, a trigger might be an email containing the word invoice. An action might then be to forward the mail to the finance team. So, a rule based AI models are like giving your computer a set of instructions, that is rules, and information, that is facts, to make it act smartly. When a specific situation matches the conditions you have set, that is trigger, the computer takes the action you have told to it. Now, coming to the main point, that is the applications of the rule based systems. Let us explore some practical applications of rule based systems in different fields. Healthcare, finance and engineering are just a few examples of sectors and applications that use rule based systems. Following are some instances of rule based systems in AI. One is the medical diagnosis based on the patient's symptoms, medical history and the test findings. A rule based systems in AI can make a diagnosis. The system can make a diagnosis by adhering to a series of guidelines developed by medical professionals. Next can be one of the application is fraud detection based on the particular criteria such as transactions value, location and time of day. A rule based systems in AI can be used to spot fraudulent transactions. The systems for the additional examination can then flag the transaction. Another application of rule based system can be found in quality control, like a rule based system in AI can ensure that products satisfy particular quality standards. Based on a set of guidelines developed by quality experts, the system can check for the flaws. Next, another is application of rule based system is decision support system. They are created to aid decision making such as choosing which assets to buy or what to buy. Like for example, in a Facebook you get the options or the suggestions, you get the pop-ups that you have buy these things, the persons have bought these things, and it can be a many combinations that you can buy. So, this is what the decision support system. In a nutshell, rule based systems make computers super helpful in life situations. They help doctors diagnose, catch fraud, ensure quality, and even provide advice. By following rules and using facts, computers become smart assistants in various fields, making tasks easier and more accurate. So, we will be seeing now the examples of a rule based system where the industries have adopted this in healthcare. So, rule based system experts have been used in healthcare to provide medical diagnosis and treatment recommendations. For example, MySyn is a rule based expert system developed in 1970, was designed to assist physicians in diagnosis and treatment of bacterial infection. Another example is Dexplain, which uses a rule based approach to assist physicians in diagnosing medical conditions. Also in finance, the rule based expert systems used in finance to provide investment advice and financial analysis. For example, FICO, the credit scoring system, is a rule based expert system that uses credit history and another financial data to assess credit worthiness. Another example of finance is Legal Rule ML, a rule based system for legal decision making. Another one of the area is manufacturing, used to improve production process and optimize supply chain management. For example, General Electric used a rule based expert system to optimize the production process of its aircraft engines, resulting in significant cost savings and improved efficiency. Below are some popular examples of expert systems. Dendral, it is used as an artificial intelligence project that was made as a chemical analysis expert system used in organic industry to detect unknown organic molecules with the help of their mass spectra and knowledge base of chemistry. MySyn, which is earliest backward chaining expert system designed to find the bacteria causing infections like bacteremia and meningitis, also used for recommendation of antibiotics and the diagnosis of blood clotting disease. PXDES, used to determine the type and level of lung cancer. To determine the disease, it takes a picture from the upper body which looks like a shadow. This shadow identifies the type and the degree of harm. CADET, it is diagnostic support system that detect cancer at early stages. So, a rule based system depends upon facts and rules that needs to be specified while creating the rule based system expert, and in the next lecture series we will discuss the concepts and techniques that is required to handle the uncertain situations. Thank you.